Hey there, and welcome. Today we're heading to the beach, but maybe not for the reasons you'd think. We're going to explore coastlines that hold these incredible secrets about our planet's past. We're talking about places where it looks like the land itself is literally climbing right out of the sea. So let's just dive right in.
Have you ever been to a coast and seen something like this? A series of massive flat steps just rising up from the ocean? It's a pretty strange and beautiful sight. And it poses a really fascinating question. I mean, were these carved by giants? Or is there some other, much more powerful planetary force at work here?
Well, it turns out the answer is written right there in the rock itself. These steps, they're actually ancient beaches and seafloors, basically frozen in time. They're clues telling us a story of a world where the relationship between the land and the sea is always changing. But that still leaves the big question. How on earth did they get way up there? To understand how a beach can end up hundreds of feet in the air, we've got to look at two colossal forces that act like giant levers on the world's oceans, pushing sea levels up and down over geologic time. On one side, we have the ice lever. That's all the massive amount of water that gets locked up in our planet's glaciers and ice sheets. And on the other side, we've got the tectonic lever, which has to do with the very shape of the ocean floor, something that's constantly being remolded by the movement of tectonic plates. Let's take a closer look at how they work. First up, the ice lever. This one's pretty intuitive. During an ice age, huge amounts of water are pulled from the oceans and stored on land as these enormous glaciers. So the more ice you have on land, the less water there is in the sea. It's a direct relationship. More glaciers means the global sea level falls. And, of course, the reverse is also true. When the planet warms up and those massive ice sheets start to melt, all that water flows right back into the ocean basins. So fewer glaciers means the global sea level rises. Simple as that. But here's a really wild part of the story. Imagine a whole continent covered by ice that's miles thick. The weight is just incredible, so immense that it actually pushes the Earth's crust down into the mantle. So when the ice finally melts and that weight is lifted, the land very slowly, over thousands of years, starts to flex back up. This process is called isostatic rebound, and it can literally lift a coastline right out of the water. Now for our second lever, the tectonic one. Think of the ocean like a bathtub. When seafloor spreading at mid-ocean ridges speeds up, these underwater mountain ranges get hotter and they get broader. They start to take up more space in the tub. This displaces the water just like adding a big rock to your bath, and that pushes the global sea level up. Slower spreading does the opposite, and the sea level falls. So we've got these huge forces, ice and tectonics, changing the sea level and sometimes even lifting the land itself. Let's move on and see how this all comes together to create some of the most dramatic types of coastlines on Earth. What we get is called an emergent coast. The name says it all, really. It's a coastline that has literally emerged from the sea. This can happen for one of two reasons. Either the sea level has dropped all around the world, or the land in that one spot has been pushed up by forces like tectonics, or that isostatic rebound we just talked about. So, if you were a geologist out in the field, how would you know you were looking at an emergent coast? Well, the landscape is just full of clues if you know what you're looking for. Come on, let's play detective. The first clue is something called a wave-cut notch. Anyone who's spent time on a rocky shore knows how relentless waves are. Over a long, long time, all that constant smashing and grinding carves a distinct groove, or a notch, right at sea level, undercutting the base of a cliff. So here's the crucial part. When the land rises or the sea level falls, that notch gets lifted up, high and dry. It becomes a kind of fossilized waterline, a perfect record of where the sea used to be, now stranded way above where the waves can reach. And that little notch leads us to our second, much bigger clue. You see, as the waves are carving that notch, they're also eroding all the rock in front of it. This creates a flat, gently sloping surface called a wave-cut platform. When this platform gets uplifted, it becomes what we see as those giant steps, a marine terrace. And these incredible features, they tell such a direct story of geologic change. Each one of those terraces on a coastline, each step, represents a time when the sea level stayed put long enough to carve out a platform. That was then followed by a period of uplift or sea level fall that lifted that platform up and preserved it, almost like a step in a giant stone staircase. So let's zoom out for a second and see how this all fits into the bigger picture. It's really easy to think of our coastlines as just being fixed, a line on a map. but they are truly among the most dynamic and ever-changing landscapes on our entire planet.
So let's quickly summarize what we've learned. First off, sea level is not constant. It has always been in flux. Second, these changes are driven by massive planetary engines, like glaciers and tectonics. Third, the land isn't static either. It can rebound and rise all on its own. And finally, these processes come together to create emergent coasts, which act like these amazing geological history books, preserving the story of past sea levels for us to read. So the next time you're at the coast, maybe look a little closer. The shoreline you see is just a temporary moment, a single snapshot in Earth's long dynamic history. It really makes you wonder, right? With our planet changing as it is today, what kind of clues are we leaving behind? And what story will our shores tell millions of years from now?